Hello, dear students. My name is Wakar Ahmed, and I teach geology at Department of Geology in Government MEM College, Jammu. So today I'll be discussing with you fourth unit of fuel geology. So specifically in fourth unit, we'll be discussing topic 4.1, which is chemical composition and physical property of crude oils. And in this presentation, uh, we'll have a discussion about what actually is oil. So, and then we'll talk about the chemistry of oil, what actually forms the oil, what's the reason behind the formation of oil or the existence of oil as a substance. And then we'll talk about the different varieties of the different types of oil which we have, and in the last we'll be talking about and discussing about the physical properties of crude oils. Proceeding further, what actually is oil? So oil, it's a natural substance which is usually found in sedimentary rocks, and it also forms in the same sedimentary rocks, and it forms over a very long period of time by a process of called as decomposition of little organisms, which eventually after dying settle at the sea bottom or in the sediments, and then they are preserved so that they are not decomposed. So, and they are just like preserved so as the carbon in them is preserved. So talking about oil, if we say that if we'll see oil as a source, it's a renewable source. Like, I mean, it keeps on replicating, it keeps on forming again and again. But since it takes a long period of time, very, very long, perhaps millions of years of time, so we end up, using it much faster as it is being created. So we can say it is like based upon the long geological time. It's a non-renewable energy source, and specifically oil to the mankind, it has been known from pretty long since ancient times, but its uses were different. It was used as medicine, it was used as a lubricant, it was used as a waterproofing agent, and for lighting purposes, like lighting a bulb, a lamp, kerosene lamps, which you might have been familiar, or which we were familiar when I was a kid, about a kerosene lamp, which we don't see much in this modern times. So, specifically, its use as a fuel, it started around in 1900s in this century only. So, basically, what actually forms crude oil is it's a complex combination of hydrocarbons. I mean, it's a mixture of hydrocarbons, you can say, and which also contains small amounts of nitrogen, oxygen, and sulfur compounds. So, statistically or based upon numbers, if we'll say, the average chemical composition is it has around 84 or 85 approximately percentage of carbon in it, and we have 13% of hydrogen, and we have 1.5 to 2% of sulfur, and nitrogen is around 0.5 percentages, and then oxygen again 0.5 percentage. So this oil we can find it, I mean, in the form of liquid, which we normally call as oil, or hydrocarbons, or this crude. It can be present as a gas as well, or again in the solid form as well, which we call as bitumen. Bitumen, it's somewhat similar to asphalt, which we use as the payments of roads and payments of road principally to make roads. And for the first oil well, it was drilled in the USA, United States of America, by Colonel Drake, and it happened in the year 1859. So let's proceed further to the next slide. So talking about chemistry, what actually makes up oil? So Oil and gas, like I said, it's a mixture of different hydrocarbons. So hydrocarbons is mm, yeah, hydrocarbons, which I can say hydro, it's made up of two words, hydro, which corresponds to hydrogen, and carbon, it's carbon. Self-explanatory. So as the name suggests, these large molecules, excuse me, these are made up of hydrogen and atoms. They are attached to a backbone of carbon. So how does our next slide? So based upon the chemistry, if you go at the atomic level of hydrogen and carbon, so hydrogen has atomic number of 2. So it has one proton and one electron which revolves around the nucleus in an outer shell. Similarly, carbon has atomic number of 6. So we can see 2 is in 2 electrons they revolve in the inner shell, and 4 electrons they revolve in the outer shell. So these 4 electrons in the outer shell, that means they are available to join with 1 electron of hydrogen uh, at multiple numbers, so they can form. So this makes a possibility of this compound to make, longer chains, as we can see. So if you know the if we call about the simplest hydrocarbon which we have, it's CH4. Like we have one atom of carbon, and then we have 4 hydrogens which are situated or placed at the 4 outer electrons of the carbon. So they share electrons and they complete a compound. So simplest of them all is methane, which is 1C and 4 hydrogens. So similarly, carbon and carbon again, they can join with a double bond, and then each of the outer electron, they can attach one hydrogen again. So we get a formula of C2H6. So similarly, we have various long chains of hydrocarbons. We have methane, the simpler one. We have ethane with the formula C2H6, and then similarly we have propane, butane, pentane, ethane, and octane. As we go, towards the right, we have more carbon atoms. Like in methane, we have one carbon atom. In ethane, we have two carbon atoms. In propane, we have three carbon atoms, and so on and so forth. So as the more carbons add up, uh, as the more carbons they link together, so we get a hydrocarbon with a higher density. That means we will have a higher dense hydrocarbon. So usually the lower hydrocarbon chains, they end up in forming gas. So and then we have the bigger chains that will end up in being in a liquid state, and the very longer chains, they will end up in being solid. So slide. So in this, we will discuss about the hydrocarbon types or series, the property which we discussed, that it has a property to join and make long hydrocarbons, and based upon the number of carbons attached, so we get a denser hydrocarbons as well. So typically in petroleum industry, we have like 4 different types of series or types or series of hydrocarbons present in crudes. So normally we have number one we call as paraffins. They are also called as alkanes, and they have the general formula of CnH2n plus 2, where n is the number of carbon atoms. So paraffins, they are from carbon 1 to carbon 40, the range. So we call them as paraffins, and they usually appear in crude oil and represent up to 20% of crudes by volume. Like if you have a raw crude oil, so in that there is a possibility of, in that 20% in that oil, 20% will be a paraffinic type of hydrocarbons. So these paraffins, they are fully saturated, like there is no double bond in it. So they are stable, and they can remain unchanged over a long period of time. And similarly, coming to the next, we have naphthenes, or we call as cycloparaffins. So cycloparaffins means like we have a cycle or ring-like structures. So and they are again saturated, and they have a double bond in them. So and the thermodynamic details or studies which we have performed on, they reveal that in naphthene we have rings of carbon with 5 to 6 carbon atoms, and they are more stable naphthenic hydrocarbons. And this particular type of hydrocarbon, it's present in crude, its composition or presence may vary up to 60% in a normal average crude oil. So moving over to the next slide, we have the third type of hydrocarbon, which is aromatics. And aromatics, it's also an important series of hydrocarbon, and it's almost present in every type of crude oil or petroleum mixture in every type of world. So aromatics, they are usually are called as, they're also called as alkyl benzenes, and have a general formula of CnH2n minus 6, where n is greater than or equal to 6. I mean, we carbon atoms or hydrogen atoms, they must be greater than 6 in number. I mean, when we have six carbons, then they will be ability, they'll have the ability to form a aromatic or type of structure. So its example is C6H6. That's the lowest form of aromatics what we have. And then the fourth type is asphaltenes, and they are composed of fused benzene ring network, and they are actually considered as a impurity kind of atoms, and are not true hydrocarbons. So these impurities, they make, they result in high molecular weight of this compound, and they are very heavy asphaltenes, and they are a major component of many tars and asphalts, which are principally used in, they are usually look like a solid, or they're really black in color, they are heavy, and we use them on our roads, to make them uh, pavements on. So this was about the chemistry and the types of hydrocarbons, and now uh, we'll discuss the physical property of this crude oil. So basically, what is physical property? A physical property is an aspect of matter that can be observed or measured physically. I mean, with seeing it and without changing it. I, without changing it, we can observe or measure it. So a specific set of properties which we have regarding crudes is uh, mole- uh, molecular weight and volume. So let's start we'll discuss specific sets of around nine or eight odd physical properties in this. So we'll start with the first one, which is specific gravity, and then we'll discuss about the volume, and then viscosity, the refractive index, fluorescence, color and order, cloud and power points, and flash points. So these are some physical uh, from now on. So let's talk about specific gravity. So if you'll, the specific gravity of a substance is defined as, it's actually a comparison of that substance, of the density of that substance to that of water in equal amounts. Like a specific gravity of crude oil, it ranges from 0.6690 to 0.9990. So light crudes, based upon specific gravity, we have classified, American Petroleum Institute, which is API. So we have light crudes, they have an API gravity or specific gravity of over 40, and then gasoline, it has near about 60. And those hydrocarbons who have in API gravity below 40 degree 40, they are regarded as heavy. And from this, you must have realized that there is an inverse relationship between API gravity and density. The higher the density, the lower the API gravity. So here is a number of API value if you want to calculate. So this is the number how to calculate the API value. And then let's talk about the volume. So volume of a crude oil in a reservoir rock, it differs uh, from when the same oil is present at the surface. Why? Because in the crude oil, there at a particular depth in a reservoir, the oil is under reservoir pressure. So at that high pressure, the volume of oil in reservoir increases. Why? Because it has lots of dissolved gases. But when we extract the crude oil, when we bring that crude oil through drilling to the surface, to the earth surface, so that reservoir pressure is released, and then due to which all the gases which are present in the crude oil they escape, hence leading to the shrinkage of the in the volume of the crude oil at the earth surface. So this was volume, and then proceeding further, uh, we have already discussed about it, volume of a crude oil under reservoir pressure and how what happens, and when we get this oil on the surface the pressure releases and we lead to volume. And then let's discuss about viscosity. So viscosity of oil is a measure of its resistance to internal flow, and then it is an indication of its oiliness in the lubrication of surfaces. So there are two types of viscosities. You don't need to go into further into detail of that. So, but just to tell you that one of the property is viscosity. Also, we check how viscous the oil is. So, the viscosity of crude oil is between 1 cp to about 4. And then another property is refractive index, which is more of like an optical property. So refractive index determines us, gives us an idea of oil, that how the ability of the oil to deflect a ray of light passing through it. So we have the refractive index of oil varying between 1.39 to 1.49. So if we have heavier the oil and lower the API, which we discussed, the inversely proportional relationship between API and density. So specific gravity actually, heavier the oil, that means the denser it is, and then it will have a lower API value and it will have a higher refractive index. So let's proceed further now. Uh, we'll discuss the property of fluorescence. So fluorescence is actually if oil is exposed to ultraviolet, so how it behaves, what kind of color it emits, it's actually a measure of that. So this fluorescence property, it actually permits the detection or identification of even minute quantities of oil during exploration. So what we do is we take samples of drilling mud and cuttings which emerge at the surface. I mean, if you are looking for a oil and you are drilling, you don't know if we encountered oil somewhere down in that. So what we'll do is we'll do a test. We'll check the fluorescence in the drilling mud. We'll check it under the UV light. So if there is somewhere oil present in that mud, so in that muck, so it will have that property of fluorescence. It will show its color like yellow, blue, or green. So with the help of that, we will be, in a way, able to detect its presence, oil's presence or crude oil's presence. So now moving further to the property of color and order. Uh, so the paraffinic oils, they are usually light in color, which have yellow to brown, and asphalt base oils, they are usually black, which we usually see all around us when there is a road construction going on. So many of them are also known as black oils. So color is usually determined by, I mean, we have an instrument to detect actual color as well, so it is say called colorimeter. So and due to light hydrocarbons, some oil is agreeably like gasoline order, like petrol. Gasoline is actually petrol. Gasoline is petrol. Here in our country we call it as petrol. So petrol has a specific scent. You might have been familiar with it. So somehow, I mean, some people they claim that I like that smell of petrol. So this is because of the presence of aromatics. So we get this pleasant kind of odor in it, in that smell, in that oil. So that's why that's the reason behind it, because we have aromatics present. And aromatics, as the name suggests, aroma. Aroma means fragrance. So oils containing sulfur and certain nitrogen compounds, they usually have a disagreeable odor. So sulfur usually has a foul smell, like something is burnt or something like that. It's that kind of odor it produces. So the odor, also based upon the order, we can differentiate that what kind of crude is there, paraffinic or aromatic, or what kind of composition. We can have a faint, slight idea about. So now moving to the next slide, we have cloud and pour points. Pour point is the temperature at which a crude oil will no longer flow. So this property tells us about the flowing property. It's actually the flowing property at a specific point of temperature. So the temperature at which appearance of waxy substance in the crude, where there appear waxy substance in the crude, so that temperature we call it as cloud point. So cloud point and pour point's definition: the pour point is the temperature at which a crude oil will no longer flow, and cloud point is the temperature at which the waxy substance in the crude appear. Okay, so what's the use of this property? This property determines the influence of low temperatures on crude oils. Simultaneously, it provides information about the amount of solid paraffin waxes contained in the oil. Okay, and the range of pour points of crude oil, they vary from minus 70 degrees Fahrenheit to 90 degrees Fahrenheit, or even higher than that. So the flashpoint property is this is the temperature at which the volatiles rising off the surface of heated oil will ignite with the flash, so on passing a flame over the surface. Like this provides some clue about the gaseous content of the crude oil. Like at this temperature, if you are, say for example, taking a crude oil, if you are checking it and you are looking for a flash point, if there are more gases present in an oil, so we'll have at lower temperatures we'll have a flash in that. Or maybe if the your crude oil which you are checking about, if doesn't have the gases content in it, so it will light, the flash will rise at a perhaps higher temperatures. So this was it about your 4.1, and hope you understood all the points, and thank you.